Hi everyone, I'm Hossein Zare-Behtash. I'm a lecturer in the Aerospace Sciences division at the University of Glasgow.
Hi, I am Andrea Cammarano and I am a senior lecturer in the Division of System Power and Energy in the University of Glasgow.
So my research is primarily focused on fluid dynamics. So I do experimentation and modeling and simulation of fluid flows over aircraft wings or through the engine, trying to understand the behavior of the flow so we can control it and design more efficient components.
My field of expertise is dynamics and nonlinear dynamics. I normally look at structures and their vibrations, especially at resonance, where they can cause damage to the structure itself, but also where the kinetic energy of the structure can be used to be converted into electric energy or to create novel propulsion systems.
So Andrea and I, we make a formidable team. We've been working together for quite a few years at Glasgow. He looks at the structural side of things, and I look at the fluid dynamic or aerodynamic side of things.
Yes, we have been working together for quite a while. And to be honest, until a few months ago, we wouldn't have imagined that we could use our expertise to tackle the problem of COVID-19. So everything really happened by chance. We were speaking about how everything was shutting down and closing because of COVID-19, and we were wondering if we could have done something with our expertise to help with COVID-19.
Yeah, and I think we had the conversation with Andrea at the beginning of the pandemic, if you remember.
Yes, I do. I remember that I was almost poking a little bit of Hossein, and I was asking, come on, Hossein, this virus spread through air. So this is your environment. This is your thing. Why don't you do anything about it?
Yeah, and this is when also I think a lot of you will remember it was it was the peak of the conversation about PPEs. There was a PPE shortage for the NHS. There were questions about the effectiveness of PPE, and that's how the conversations between me and Andrea started. But very soon we realized that it was a much bigger problem, more complicated than we thought about, but at the same time that we could actually use our expertise to do more than just look at PPEs.
Yes, I remember that originally we were trying to test efficiency of efficacy and efficiency of PPEs. And then we thought, wait a second, if we can simulate what happens to the flow around and through PPEs, maybe we can simulate the flow and the droplets and the dynamics of the droplets, which are the main carrier for this virus, and therefore predict where the droplets go and or where the virus is transported.
But if you think about it, sort of coughing and sneezing and speaking have been identified as the mechanisms to spread the virus. But to really understand the risk in an environment, you need to take into account the size of the room, for example, that you are in, how many people are there, how many people are talking or coughing and sneezing, is there ventilation? So if you add all these parameters up, you realize it becomes quite a complicated problem that could take a very long time to solve using numerical modeling or doing experiments, which could be quite expensive.
So you can imagine that every time you change one of those parameters, the entire simulation becomes a new simulation, and the entire experiment has to be repeated. And this would be far too expensive, both in terms of time and in terms of resources. So that's where I thought that some of the techniques that I was using for linear dynamics and dynamics to reduce the order of the models. A reduced order model is a model which is much simpler. It's almost a model at the essence of a much bigger model, which is capable of capture only what you are interested in. And by using reduced order model, you can reduce immensely the computational time and the computational resources.
But at that time, that's when we also realized with Andrea that to solve problems such as this, it requires skill sets sort of beyond what both of us were capable of. And we started looking through our network of friends and colleagues at different universities, and we realized that there are some very capable people who are sort of at the top of their field that could really contribute to this project and to help us answer some of these questions when it comes to changing parameters and how that affects the risk of infections.
That's how we came to collaborate with the University of Strathclyde, the University of Queen Mary in London, the University of Imperial College in London, and Cambridge University. Each of them brought a set of expertise that we did not have, and which could contribute in making our predictions more accurate and faster. So together we decided to embark in this challenging project, and fortunately we managed to have support from UKRI, and we are just at the beginning of this new experience, of this new adventure, and hopefully soon we will have this tool which is capable of predict the risk of being in a room with somebody who is infected, and taking into account the dimension of the room, the ventilation, all the parameters that Hossein mentioned before.
Yeah. So as Andrea said, because we've just started on this project, we don't have a website yet, but feel free to contact either myself or Andrea, and you can follow, hopefully very soon, our progress on the website.
Yes, and should you be willing to help us to contribute, or even just talk to us and share with us some opinions, some ideas, we are more than happy to hear from you. Please get in contact with us.
Yeah, so thank you very much for your time, and we hope that you found our project interesting and you will follow us. Thank you very much.
Thank you very much. Bye.
Bye.